Okay, so yeah, hi, very good evening to all of you, and I hope I'm audible, right? So, class, just let me know I'm audible to everyone. Hello, Vaishnavi, Preeti, Hemant, Vijay. Let me just
Yes, sir, you are audible.
okay. Now, first time I'm getting someone voice, right? Hi, Vijay, how are you? Since last multiple days, I'm trying to reach all of you guys to just get connected, right? So that you can share your doubt and we can connect and we can just understand like, are you getting the points or not, right?
Yes,
So
sir.
Vijay, I hope like you are doing like all the practice, whatever we have learned so far, right? Okay.
Yes, sir.
Okay, the screen is already visible and I have already started the recording, right? So let me just directly start with the part. Guys, in the last class, we have already completed our the ML like overall logistic regression with the multi-class classification, right? So today, let's just start with the another ML model that is knife based, right? So my screen is visible now. Just to confirm me once again, right? Okay. So if you want to do it, practice along, so you can do it, right? Let me just share this link with you. And today's project is very good, and it is generally being asked by the interviewer as well. And you're going to learn something new, right? So just copy this link, okay? And you can just take a reference of this notebook, and you can do the practice parallelly with me, right? Okay. So first of all, the name of project is spam classification using machine learning, right? So we generally try to understand the ML model, different types of ML model, but this time we have some sort of different data, and data set is like related to the email kind of marketing, where we generally get some email based on like their whether they are spam email or like some sort of ham email, right? So the project is completely we have to create a ML model, and we just simply give the email or like messages from the email, and that ML model generally try to predict whether the given email message is a spam one or like the ham one. Ham one is like the good one email, you can say, right? So spam classification using ML. Okay. So candidate, before starting this, we have to understand some concept, because this spam classification is generally based on one machine learning model, and that model name is naive Bayes, right? Okay, before we just start this knife base or like naive Bayes, so we have to understand one thing. The model name is naive Bayes, and it's completely based on the Bayes theorem. Okay, so how many of you are already aware with the 11th class topic, that is Bayes theorem? It's completely based on the conditional probability. How many of you have already performed all this kind of operation? Just let me know, candidate. It's like a Bayes theorem. Bayes theorem is just nothing. It's a completely mathematical formula we generally use to like work on the conditional probability. Before directly understanding this like conditional probability, first of all, we have to understand what exactly the probability is. I hope everyone knows the point, like what is probability. Probability is just to check the likelihood of an event. Like we have to calculate the probability to just how the event is like going on. Okay, we have some sort of total number of observation, like the number of favorable outcome divided by the total number of observation, right? I hope everyone aware with this term, right, in the probability. So if I'm tossing my coin only once, and I know I have a probability of getting head is like 50%, because the favorable outcome is like 1 and the total possible outcome is 2. So it's like 1 upon 2, and which is close to the 50%, and it is like the probability of getting head is 50%. In the same way, probability of getting tail is again the 50%. This is the very basic probability, right? You can just simply get the probability by just checking the number of favorable or like the total favorable outcome divided by the total possible outcomes, right? Since we are tossing the coin, so the total possible outcome can be like head and tail. So it's like the two. And the favorable outcome, because we are calculating the probability of head now, so the favorable outcome is like 1. So that is a very basic probability. Before understanding this Bayes concept or like a Bayes theorem, you have to understand first thing, that is the probability concept, right? Because the Bayes theorem is completely based upon the conditional probability. And if you just apply for any sort of interview, the interviewer generally asks you the mathematical intuition. Intuition are like the fundamental blocks of all this ML model, right? So I hope everyone is getting the point. What do you like? What exactly this probability theorem is, right? So let's just understand the probability in depth so that you can easily understand the Bayes theorem as well, right? You have already have this type of concept which is like a deck of card, right? In the deck of cards, we generally use this to understand the probability concept, right? You can use the lead code problems to understand the probability concept as well. And let's just take the very basic example, right? Guys, we know that in the deck of card we have total 52 cards, right? See, you have to participate in the question and answers candidate, because this time I don't just want to explain the things. I want a two-way confirmation whether you are getting the point or not, right? So in the deck of cards, we have a 52 cards where the each card have their separate name, like the clubs, spades, hearts, and diamonds. And each groups we have total 13 cards, 3 followed by the face card. J, Q, and K are the face card. And the first one is like the ace card and then followed by the digits card. Okay, I hope everyone is getting the point, right? So in the all deck of cards, we have two different colors. The first one is like the black color. Second one is like the red one. The black color, we have two different cards. The first one is club group, second one is spade group, and then followed by the red color. The first one is heart group, and second one is like the diamond group, right? Again, I'll repeat the same thing. We have a three face card in each group, and that makes the overall 12 face card followed by 3 into 4. It's like a 12 face card of the overall deck of cards, right? I hope everyone is getting the point, right? Now I'll ask some question now. So let me just take a screenshot or like a copy of this image, and let's just do some probability experimentation, right? Okay. So guys, just try to give the answer of all these questions, right? And I know like you guys have performed all these probability concept in your secondary school and all, right? Okay. So the very basic question, first question, what is the probability of getting J? Or like, let's just change the question of what is the probability of getting K or like a king card out of deck of card? Just let me know, candidate. What is the probability of getting K out of deck of cards? Guys, you have to participate in this question answer, right? Because this time I'll don't just simply explain the things. You have to give the answer as well. Hemant, Spurti, Neha, Priti, Vaishnavi, candidates. What is the probability of getting king out of all 52 cards? Let me know the answer fast. What is the probability of getting king out of all rest of 52 cards? Guys, do it fast. Everyone, are you getting my voice now? Class? Just let me know if you're not aware with the concept, right? See, let me just explain. Okay, I hope I got some answer, like 1 by 13, okay? You have directly give this answer 1 by 13. Let me just break this. Because we have 4 king cards, so let's just make it this way. We have, first of all, face cards. The face cards are like 12 face cards, and all these 12 face cards, we have 4 king cards, right? 4 cards. And because the total number of cards are like 52, so the probability of getting king, let me just write this, probability of getting king is like total favorable outcomes. It's like the total cards of total possible king cards is like 4, and divided by total number of outcomes, or like total possible outcomes. The total possible outcomes is like 52. And once you solve this now, you will get something like this. 4 by 52, it's like 1 by 13. And everyone is like giving the same answer. It's like 1 by 13. Sharath and Vaishnavi, very good, right? So 1 by 13 or like 0.07 is the probability of getting king, like king on the deck of cards, right? So let me just change this to 1 by 13. This is the probability of getting king out of all deck of cards, right? Now let's just ask another question. What is the probability of getting queen of hearts? What is the probability of getting queen of hearts? So we know that we have total 30 like 13 cards, of hearts, and in this 13 cards of hearts, we have only one queen. So the probability of getting queen of hearts is like 1 by 30, right? Okay, now let's just ask the another question. What is the probability of getting ace? What is the probability of ace, getting ace of black colors? Just give me the answer, candidate. Probability of getting ace of black colors. Guys, let me know the answer. Probability of getting ace of black colors. We have total 52 cards, and in this 52 cards, we have two ace cards with of black colors. Can I just say this? 2 divided by 52, and the answer is like 1 by 26. Okay, you can just simply like solve this. 2 divided by 52 is like 1 by 26. I hope everyone is getting the point, right? Vaishnavi, Sarath, and rest candidates, probability of getting ace of black cards, black colors card, right? Because we have overall 26 card, and inside the 26 we are just having only the two ace color, and we just want to check the ace of black colors is like two possible out of the overall cards, and the overall cards are like 52, so you can just solve it like 2 by 52 is like 1 by 26. Okay, this is the very basic probability. Okay, now let's just ask another question. What is the probability of getting one card and it belongs to face card? What is the probability of getting a card that belongs to face card? Now let's just calculate this probability of getting a face card. Now we know that we have like 12 possible face card. So face cards are like 12, and the total cards are like 52. So you can just solve this. Probability of getting face card is 12 by 52, and you can just solve it to 12 by 52. What is the value of 12 by 52? 4 threes are 12, 4 13, something like this. So you can just say 3 by 13, I think, right? 12, yes, 4 3 times 12 and 4 13. Yeah, 4 13. Okay, so you can just say 3 by 12 is the probability of getting a face card. Is that clear? Can you just let me know if you understand this? Probability of getting a face card is 3 by 12. Now this is just a basic probability, right? Let's just ask another question. What is the probability of getting ace out of all cards? Now we know that we have all like 4 possible ace, and the total cards are like 52. So the probability of getting ace of any colors, probability of getting ace of any colors is like, we have 4 ace card, so you can just write 4, and the total cards are like 52. So you can just simply solve this. Probability of getting ace is like 4 by 52, and it is 1 by 13. So these are the very basic probability where you can just simply get one as a favorable outcome and then divided by the total possible outcome. That makes this as a very basic probability understanding. Now just let me know if you got this point, everyone. Yes, the rest candidate, guys, just do it fast. Let me know if you're getting the point right. Why we are understanding this? Because we need to understand the concept so that we can further plan it for like the conditional probability, right? Now let's just understand what is conditional probability. If anyone has to like have to ask any question, just let me know, guys. Any question? Instead, like on this particularly deck of card, if you have any question, just let me know. Whether it is what is the probability of something this, that, just ask me any question if you have, candidates. Or good to go, right? Okay, so I'm not getting any questions right now. So let's just move to another topic. Okay, so let's just start. What is conditional probability? Before understanding the conditional probability enough, the first thing that we need to understand is called a Bayes theorem, right? Now, how many of you heard the Bayes theorem? Candidates, anyone? What do you understand by the Bayes theorem? Bayes theorem is completely based on the conditional probability. Now, what is conditional probability? In the conditional probability, one event already happened and one event already occurred, right? And you have to check probability of another event based on the previous one. Probability to check probability of another event that based on the first one. This is called the conditional probability, where the first event already happened or like occurred, and you have to check the probability of another or like the second event that is generally based on the first one. That is called conditional probability. It's like the probability that is based on some conditions that makes this as a conditional probability. And we have a Bayes theorem for that. And Bayes theorem is something look like this. You can just simply copy this Bayes theorem. Just go to this Google, and this is the Bayes theorem, right? Let me just pick this one, right? This one is good. Where we have a 4 different nomenclature naming convention, right? You can just take the naming convention like this. The probability of A by B. Now, what is the probability of A by B? Probability of A when the event B is already given. That is called probability of A by B. Now, let's just understand this equation. Okay, let's just first understand this one, right? Probability of A by B is like probability of A when we have the probability of A being true if the given B is true. It's like we already know the probability of B and we have to calculate the probability of A. It's like we have already given the probability of face card. Now just we want to check the probability of a king one. It's like the B event already happened, and based on this B event, we need to calculate the probability of A. That is called posterior event, right? The second one is like the likelihood. The likelihood is like the probability of B when the event A is already true or like event A already occurred. That is, you need to calculate the probability of B, and then followed by the individual probabilities like the probability of A and then divided by the probability of B, right? So this generally refers this as a Bayes theorem. Now let's just understand this Bayes theorem based on with cards example. Okay, I'll use the Gemini example one, right? Based on with card example, then you can probably understand, right? Yes, this one. Now let's just understand. This is the example, right? We have to calculate, the goal is we have to calculate the probability of king when the face card is given. And we know that the probability of king when the face card is given, we have only the 12 face card and followed by the king one are like 4. And it's like 4 by 12, it's like 1 by 3. We have already calculated this, but how to calculate this with the help of a Bayes theorem, right? This one. So let's just copy this, go to this paint tab, and we'll plot the, like we'll give the value one by one based on this probability, right? So now what we want to calculate, we have to calculate the probability of A by B. It's like we have to calculate the probability of king when the face card is even given. When the face card is already given. This is called my conditional probability. I'll just simply copy and paste one by one, right? This makes this as a probability of A by B. Are you getting my point, candidate? This A by B is like probability. You have to calculate the probability of king when the face card is already given. We can mentally calculate this. It's like we have total 12 face cards, and out of 12 face cards, we are only having the 4 king cards. It's like 4 by 12, and 4 by 12 is like 1 by 3. This is the final answer that you can like exactly get. But the problem is we have to calculate this with the help of a conditional probability. So that is the reason we are placing the formula like here, right? So here we are calculating the probability of king when we already know the probability of a face card, right? Now this event is like the posterior event, and we have to solve it based on the likelihood and the prior and the marginalization, right? Some sort of like this, okay? So let's just calculate the probability of likelihood. It's like the probability of B when the event A already given. So you just need to reshuffle this, right? Or you can just simply change this probability of face card when the king is given. Just understand, we have to calculate the probability of face card when the king is given, and we already know that the king is already a face card. So the probability of face card when the king is given is 1. Guys, are you getting my point now? Everyone, probability of face card. Yes, you can understand here. Probability of face card when the king is given. And we already know that king itself is a face card. So if you're just checking the probability of face card when the king is given, so the face card itself is a king card, right? So you can just say it is 1. And this is called the likelihood event, right? So let's just pick one by one the probability of king. We have 4 king out of total 52 card. So the individual probability, it's like the probability of king. You can just take a reference of this. Probability of king is like 4 by 52 because we have only 4 king and out of total 52 card. And this is just nothing, the probability of A. It's like the probability of A. We'll place the value here, right? Okay. Let's just paste it here. Now, the second is like the probability of the likelihood is like the probability of face card when the king is given. And we know that if we are getting any face card, and if we are getting any like king card, the king card already itself a face card. So there is no need to check the probability because the probability itself is one. Because all king's card are like a face card. It's not always the king one, the king, queen, and the J card. All these cards are the face cards. So we will always get the probability of one. It's like the probability of likelihood, right? We can just take a reference of this and let's just take a screenshot and you can just paste it here. Why I'm doing this? Because I want to relate it with the formula, right? Whatever the formula that we have, right? This is something like this. And it's like the probability of B by A multiplied by probability of A. So you can just apply the multiply sign here. This Bayes theorem is completely based on this concept, right? It's like the conditional probability. Okay. Now we have to divide it by the probability of B. And the probability of B is just nothing, the probability of face card. Now we know that out of total 52 cards, we have 12 face cards. So you can just simply check 12 by 52. Here you are getting the same. That is called evidence, right? So let's just take a screenshot of this. Probability of face card is like 12 by 52 and you can just solve it like 12 by 52 is like 4 3 times 12 and 4 13. It's like 3 by 13. It's the probability of face card. Okay. So let's just paste it here. Just like the probability of event B, and event B is called the evidence. Evidence is like this event already happened, right? And if you just solve this candidate, if you just put the value here, you are getting 1 multiply 4 by 52 divided by 12 by 52. So let's just solve this, right? Then you will get the probability of king when the face card is given. You can just simply write the equation here. It's like is equals to, and instead of directly solving this, now let's just rewrite this again. We are getting the values like probability of face card when the king is given, it's like 1. So let me just solve this is equals to 1 multiply by the probability of king. We have total 4 king card out of 52 card. Multiply by 4 by 2, 52. It's like 4 by 52. Okay. And then divided by the probability of face card. We have 12 face card now, so the probability becomes, we can just simply check that we have 12 face card, right? Where is the 12 face card? Like here, 3 3 3 3, and all becomes 12 face card, right? So it's like 12 by 52. And let's just solve this 12 by 52. Okay, 12 by 52. Now you know that you can directly eliminate the denominator part because it's the same. So let's just cut this. You can simply cut this 52 by 52 and you will get the answer as 4 by 12. And once you solve this, the answer is 4 by 12, 4 by 12, 4 by 12. You will get the final answer as 1 by 3. Let's just cut this and the final answer will become as 1 by 3. That is called the conditional probability. I hope everyone is getting my point, candidate. Instead of solving this with the help of Bayes theorem, we can directly solve this. We know that we have 12 face card. So you can just simply write the value here. It's like 12. Okay. And out of 12, how many king card we have? We have 4 king card. You can just directly solve this. Instead of doing this, all this kind of like formalization, you can directly sort out this and you will get the same answer as 4 by 12 and then finally 1 by 3, right? But why we are understanding this? Because this is the Bayes theorem. The Bayes theorem say the probability of king when the face card is given is depend upon the probability of face card when the king is given and then followed by the individual probability. And that is the reason we are understanding this Bayes theorem. I hope everyone is getting my point, right? Instead of this face card by king, we generally refer this as a by B. A is like the probability of king, B is like the probability of face card, and the B by A is like probability of face card when the king is already given, and the probability of A is like the probability of king, and the probability of B is like the probability of face card. I hope everyone is getting my point, guys. Are you getting my point? Just let me know. Candidate, everyone. Candidates, just write it. Got it. Perfect. So this is the complete explanation of the uh, conditional probability, right? Now you can just take a screenshot, and now you got the point why we took the example of this king face card and the queen card, so that you can relate how to connect it with the probability of like the conditional probability. Although you can directly get the answer, but you have to solve this with the help of probability of the likelihood prior and the marginalization, and sometimes we refer this as an event, like the evidence, probability of evidence as well, right? So I'll just take a copy of this, all one, control A, control C, and let's just paste it here. Now we know that this is called the Bayes theorem. Guys, let me know if in case of any issue, because the next model that we are going to understand is a naive-based model, and we have to understand before implementing all these model, right? The Bayes theorem. So we already got to know what is Bayes theorem. Now let's just understand the meaning of naive, or like the naive. Okay, the meaning of naive. The meaning of knave is like a very simple kind of person. Is like the in Hindi we generally say this as bhola wala, but you can just say a person which has like the lack of experience, or like very innocent person. Like we can simply say this as an innocent person. Now, now the problem is why we are using this innocent word here, right? This is a like part of this machine learning, but why we are considering this as an innocent one? See, there is a context, right? The context is the knife means, or like the knave meaning here. It's like it just assume ML model, like this naive based ML model just assume, let me just write this model, this ML model just assume that there is no correlation between given X features. Now what I'm saying, we know that we have to generally identify the correlation between X and Y. If we are getting, let me just write this, if we are getting correlation between X feature 1, X feature 1 with feature 2, or with feature 3, or so on. So this is problem for machine learning. This becomes problem for ML. And that problem we generally refer this as a multi-collinearity, right? That problem generally is as a multi-collinearity. What is that, candidate? Multi-collinearity. Now let me just show this. What is multi-collinearity in machine learning? A multi-collinearity is just nothing. It's like the two or more independent are like the X feature, are highly correlated. And we have to avoid this because it can like increase the complexities in the model, and the model cannot perform well. And we have to avoid these complexities to just simply eliminate the highly correlated factors, or like highly correlated features. And that because of the multicollinearity, and the multicollinearity is just nothing, it's like a correlation, or like the highest dependency of X feature 1 with the X feature 2. So in the practical situation, we need to eliminate or remove this feature. Like there should be no correlation of X feature 1 with X feature 2. But we know that, but we know that, but we know that in actual situation, we cannot eliminate one. They might be like we'll get the correlation between X feature 1 and X feature 2, right? So that is the reason this knife behaves like let's just pre-assume. It's like the pre-assumption. Let's just pre-assume that there is no correlation, although there is correlation, but the naive is like it just assuming that there is no correlation. We know that tomorrow will going to be like rain, and we are like 100% sure about that, but we are just assuming that there is no chances or like coincidence of getting rain tomorrow. So we are just assuming that we are like such kind of innocent person, and that is the reason we are like assuming that thing. So naive is like it's just a kind of assumption, although we have a like correlation, but it just assume or like pre-assume that there is no such correlation between features. But in practically, we know that there is a correlation, right? So it just assumes that there is no such uh, that there is no such correlation between the given features, right? And then it will apply the Bayes theorem on that, and then you can probably uh, sort out, or like you can predict the classify value, or like whether the given mail is the spam one or not, right? I hope everyone is getting my point. What is the meaning of knife, or like the knife word here, guys? Let me know. I hope everyone is getting the same, right? Class, is there an issue? Is there any doubt with related to the knife word? What is the meaning of knife? Knife is like just a kind of innocent thinking, or like the innocent pre-assumption, but we just pre-assume that there is no correlation between the feature 1 and the feature 2 and the so on. But in practically, yes, there is a correlation. So we are just pre-assuming that, let's just consider there is no such correlation between feature and feature, and there is only correlation between feature and the target. And that makes that this model as a naive model. Naive is like the innocent model. And why we are using the word Bayes here? Because it's completely based on the Bayes theorem. And we know that how to use the Bayes theorem. The Bayes theorem is something like this. Where the probability of A when the event B is already given, followed by the probability of B, and then some sort of individually probability, like probability of A and the probability of B, right? And you can just get this example with the help of like probability of king when the face card is given, and so on, right? I hope everyone is getting my point. Can you just write in the message box, class? Is that clear? What is the meaning of naive and the Bayes in that all naive based ML model, right? We generally use this naive based ML model to simply identify, or like generally use in the textual classification, right? We generally use this in text kind of work. Now, text kind of work is like sentiment analysis, okay? Spam classification, positive or negative review analysis, right? Okay. And sentiment is like whether the given tweet on the Twitter or like on the X is a positive tweet or like a negative tweet. So it, you have to just check the sentiment of like the movie sentiment, whether the like the follower or like the customer are not going to particularly watch this movie or like the web series. All these are the sentiment, right? So we generally use the naive base when we have the textual data kind of work, and it mostly used in the sentiment analysis, spam classification, positive and the negative review, or like the news analysis as well, whether the given news is a fake news or versus actual news, right? If we want to perform this kind of ML model classification, so guys, it's recommended to use this naive based ML model. I hope everyone is getting my point. Are you candidate? Just let me know, right in the message box, class, if you are getting this point. So we generally use this naive-based ML model when we have a textual kind of data related to the sentiment problem, spam classification, positive and negative review analysis. Now let's just start with the spam classification project, right? Okay. So we already know that like we have to start with the like load one is all about step one is all about like the load important module. So I'll just simply copy modules, right? I'll not write the each code one by one. It will take time, right? You are already aware with that. I hope everyone is getting my point, right? And step one is like load important modules. Now we know that we are not going to use the linear regression, right? And the errors as well, like mean squared, mean absolute, because the problem is related to the classification one. So instead of this, rest the everything will remain same. So let's just import the naive based model, and naive based gives the three different kinds of model, right? I'll just simply let you know what exactly all these are. So from sklearn, just go to first of all base, and inside this naive base, you will get three different models. The first is called multinomial naive base. Second one is called the Gaussian naive base. And third one is called the binomial knife base, right? Or like the Bernoulli knife base. Okay. Now let's just understand the meaning of all three one, right? When to use which one. We have a different stages of like stages of use cases when to use which one, right? Let's just start with the first one, that is called Gaussian knife base. We generally use the Gaussian knife base when we have a normal distribution kind of data. Now the normal distribution something like this. I hope everyone has seen this kind of like visual in their statistics class. This is called the normal distribution curve, and this normal distribution curve is like the bell curve. Okay. If we have any data or like any feature data, that generally if we just perform the EDA and if we are getting any sort of distribution like this normal distribution generally referred by as a Gaussian distribution. It's like the standard data or like the bell curve kind of data, where the first value is like the zeroth value is like derived by the central tendency, which is the mean median mode, right? And then followed by the one standard deviation to the right side, and then followed by the one standard deviation to the left side. It's like the one standard deviation, right? So you can just simply take a reference of this when to use which kind of knife base. So if we are getting any data like in sort of height, weight, or like salary, some sort of like this, so you can use the Gaussian knife base. And when to use the Gaussian knife base, when the distribution is some sort of like this, like a normal distribution, so then you can use the Gaussian knife base. Now, what about the rest one? See, like let's just first understand the Bernoulli one, right? Bernoulli one, when we have a some sort of very like basic analysis, is like you just need to check the whether the given word is a positive word or like the negative word, sentiment analysis, or like where the output is like the binary or like Boolean in nature. So you can just take a reference or like use this Bernoulli knife base. Since we are getting data related to the text classification, it's like the you need to identify the overall words where each mail can be spam and the ham as well. Ham is like the actual mail, spam is like the fake mail, right? So we'll generally use the multinomial knife base in this case. So to make it easy, the Gaussian generally be used in when we have a normal distribution data. We use Bernoulli when we have a different types of analysis, but multivariate kind of analysis, but the data should be like in the textual in nature, and you can simply represent it by the 0 and 1s, right? In that case, we can use this as a Bernoulli knife base. And what about the multinomial knife base? When we have a multiple or like very huge amount of corpus data related to NLP, natural language processing, and the text classification, then in that case, we will use the multinomial knife base. Here, we will use the multinomial knife base because the problem is related to the multiple corpus of data. Okay, so let's just take a difference of this of each Gaussian knife base, multinomial knife base, and so on. I'll just simply paste the figure here. Interview generally ask all this question, right? When to use which one? Since we are just understanding all the concept now, so right now we'll use the all three models: multinomial, Gaussian knife base, and the Bernoulli one. But the multinomial is recommended in this problem, which is the text classification. If you're getting the continuous data, continuous are like the numerical value. Okay, the numerical value or could be like the float value, integer value, height, weight, and some sort of like this. Then you can use the Gaussian distribution, and you know that you can only plot the distribution plot if you are getting the distribution like something numerical one, so you can use the Gaussian distribution in that case, right? And the Bernoulli generally we use when we have the binary text classification like 0 and 1. In this like case of spam classification, we can use the Bernoulli one as well, right? So let me make it more easy. Right now we will not use the Gaussian knife base, we can use the multinomial and the Bernoulli as well, right? Bernoulli knife base. So let's just first call the data, right? So the step 2 is all about to import the data. Import the data. Step 2, load data set. Because this is the problem related to spam and ham. So you have to click on this, go to this upload option, and I'll give you the data set, and the name of that data is spam data set, right? Let me just search the spam one. Okay. If you want it, you can let me send this data with you guys. Can I send it here, right? I'm not getting the option to send it here. So let's just do one thing. I'll just go to this my GitHub profile and let's just upload the data here directly. And you can all of you have this GitHub ID now. So you can just simply download the dataset from here. And if you want to directly use it from here, you can use it as well, right? Spam. Okay, since the data is uploaded successfully, let me just click on this. And you can take a reference of this CSV data as well instead of directly calling it from the Google Colab. Let me just share this screen and you can use it parallelly as well, right? So instead of using this data, now let me use the GitHub one so that you can also repeat the same step, right? So the dataset URL is this one, right? Something like this. And you know that PD dot, because the data set in like CSV format, you can use this read underscore CSV, just simply give the URL and you PD is not defined. Why we are getting the PD is not defined? Let me just run this code, right? We're getting PD is not defined, right? Okay. So the problem is like error tokenizing data, some sort of like this. Okay, now let's just do one thing. You can just make it question mark raw is equals to true. Okay. This is the argument that you generally pass. If you're not invalid URL cannot contain something like this. Let me just try with this one. Raw is equals to true. Okay, now it's working, right? See, yeah, you have to do some changes, right? This raw is equals to true is like consider this as a raw file, and you can directly import this from the URL, right? If you're using the direct URL from the GitHub now, so you can use this one, raw is equals to true. Now, if we have loaded this successfully, so let me just use this or like store this inside the data frame, and this is some sort of sample that we are getting, right? Now, the problem is we are only having the textual data right now, and we know that ML only works with numerical data. ML only works with the numerical data. Okay, now let's just do some perform EDA part because the data is like in the data frame format. So let's just run the shape first of all. SHAP. The shape is like we are getting some sort of 5,572 rows and only two columns. The first column is my X column, this one, and this one is going to be my Y column. The Y column, we have the category ham and the spam. Let's just check some sample again, sample of 5. And you will get some like a message with like ham one, ham is like the original email, or like spam one is like the fake email. Okay, so let's just run the sample again so that you'll understand the some sort of different emails you have, right? Use your unique user ID is something, this is the spam email. Are you still playing with Gotham? This one is ham, like ham is like the original one, right? You can just check the multiple samples. Okay, now the problem is like because we have all data in a textual way now, or like a textual nature, so we have to convert this into numerical one. See, since that category has only two information, the one is ham and the one is spam, so you can do it with the mapping method. But the problem with this message one, right? We are getting multiple message and we cannot use the one hot encoding or like the pd.getDummies that we have already performed in the last class, right? Or like the mapping one. If you are not aware with the term pd.getDummies, so I'll let you know in the upcoming class, right? So the problem with this message, now let's just call one message first, df, and go to this message and just drop the like run this series, and let's just call a sample of anyone, and you are getting the data like this, and you can just simply turn it to values, so you will get the message like this one, and just simply slice this one. Okay, got your mail, Dilip, thank you so much, Munchan, look forward to lots of support and so on, right? These are the some sample of the email, right? When slash where do I pick you up, and TMR Tim, some sort of like this kind of message. These are the same like sample messages, right? Now we have to convert all this message into the vector one. Since all messages are textual in nature, we have to convert this to numerical one. And this time we have one technique, and that technique is called the CountVectorizer technique. Let me just show you what is that CountVectorizer technique, right? This CountVectorizer technique is the popular one. First, I'll show you on the Excel file, then you will probably understand what is the CountVectorizer and how to use this CountVectorizer, right? Okay, let me just go to my Excel, and let's just understand this. What is this count vectorizer and how it can simply convert the textual data or like the textual email data into the numerical one. Okay. Suppose I have some data like this: movie reviews, and the sentiment. Okay. And we have only two types of sentiment: positive and the negative. Positive, negative. Okay. Now let's just take some reviews. I liked Dhoom 3 or like Dhoom 3 very much. Okay. And the positive is like Border 2 was very awesome movie. Okay. And negative is like, let's just take any example of, well, I usually don't watch that much movie. That is the reason I'm not getting any negative movie name right now. Guys, suggest me any negative movie name, like the negative reviews. Acting was like acting was very bad. Okay, acting was very bad. And let me just take any movie name, like Three Idiot. Well, the movie is very good, but just for like understanding purpose. Okay, acting was very bad, like in Three Idiot movie. So we have all these reviews, right? Now we know that the positive and the negative one can be easily converted into the numerical one, like 1 1 0. Right? Zero is like the, or you can just say 0 0 or 1. 1 is like the negative and the 0 is like the positive. You can just give the sentiment like this. This one is very easy to convert this sentiment into the numerical one. Now what about this one? How to convert all this data into the vector kind of format? So guys, for that you have to understand one thing. And see, you don't need to generally like do this thing manually. We have a technique for that, right? Let's just understand inside Excel first of all. First of all, you will just do one thing. You will combine all the reviews, right? Let me just use the function that is text join, and I'll just simply combine all my text like this. Okay. And now I'll get the proper corpus like this. I like Doom 3 very much. Border 2 was very awesome movie. Acting was very bad in 3D, like this. I'm getting some sort of corpus like this. Now what I'll do, I'll just copy this corpus and paste it as value, and we'll get the data like this. Now what you have to do, just simply copy the corpus. Okay. But exactly if we are not using the any methodology or like the model approach, so we have to use this approach, right? Let me just pass this inside the dummy one. Okay, I like Dhoom 3 very much. Border 2, something was this very awesome movie like this, acting and so on. Right? Now before converting this to count vectorizer, na, you have to convert this to lowercase. If you convert this to lowercase, na, you will get the dummy data in a lowercase format, right? And if you are getting any like sort of repetition kind of word, like is there any? Yes, very are we are getting very word as two times, was as like the two times word. Okay, and there should be some more common words that we are getting more than two or three times, right? So you have to remove all the words. Now let's just remove. So you can use the Python approach. Well, it is not recommended. We have a module for that that can easily perform all these tasks. But just for sake of understanding, we are performing this, right? Dummy.split. This split method allows us to split all the text, right? Now let's just keep the unique values only. So we can use this set approach, and set will try to convert all these data into the universal set where the each value can be treated as only one. And once you get this set, you can convert this to list, right? Let me just convert this to list again, right? Now you are getting the values are like Dhoom 3, like 3 border, awesome, very like movie Dhoom 3, 2, and sort of like this, right? Acting idiots. And if you just turn this to like this, you will not get the 3 multiple times, right? Dhoom 2, in much, acting idiots, bad was. These are called my candidate tokens. The tokens are like, you can just simply say the vocabulary. Vocabulary is like the complete like overall unique words that you have. Let's just write this as a vocab. Now we are having only the limited words, and if we are having the repetition of word, we are just simply considering this as a single unit one, right? Now let's just print this vocab, and we are getting the list like this: 3I, border, awesome, very liked, movie, Dhoom, 2, in much, acting, idiot, bad, was. Okay, now what you have to do, just copy this, and instead of all these one, because we just want to convert this data into the numerical one, now I'll just simply paste here, right? Now what you have to do, this is called my vector information, right? Now you have to just simply check whether you are getting any word in this particular given reviews or not. Is there any three word in this? I like Doom 3 very much. If it is, you can just simply write one. Okay. Is there any I word in this? If it is more than two times, so you can write it two. Yes, we are getting I words in this movie, so you can just give it one. Is there any border word in this candidate? Just let me know. No, there is no border, so you can just turn it to 0. Is there any awesome? No, it is not. Is there any very? Yes, it is. You can just write the one here. Is there any like word? No, there is no like. Yes, we have a like word. Is there any like movie? No, there is no such movie word. So just turn it to 0. Is there any Dhoom word in this? Yes, we have a Dhoom. Just turn this to 1. Is there any two word? Is there any two word? No. So let me make this 0. In much, acting, idiots. Is there any in? No. Much? No. No. And acting? No. And idiots? No. And what is the final word? Is like bad and was. Is there any bad and was? No. So you have just simply converted, guys. You have converted this I like Dhoom 3 very much to this vector. Now, can I just say that instead of this movie, instead of this review, I can just simply say this kind of this kind of like vector is represented by the previous statement, or like the previous movie, or like the review part. So now we have simply converted our review part into the numerical one, right? Can I say this in a candidate? Guys, are you getting my point now? We have simply converted our like, textual data into the numerical one. Guys, let me know if you're getting the point. Everyone, candidates. I hope everyone is getting my point, right? How we have converted the movie reviews into the numerical one, and this technique is called the count vectorizer technique. This is the technique of count vectorizer, where we no need to perform the count vectorizer manually. We have a module for that, but this method is generally referred this as a count vectorizer. Now let's just pick this one as well. Border. Is there any three word in this? No. I word? No. Border was yes, it is. Awesome word? Yes, it is. Very? Yes, it is. Like? No. Movie? Yes, it is. And what about Dhoom 2? So the Dhoom is 0, the 2 is 1. And in much, acting, idiots, bad. So in, is there any in? No. Much? No. Acting? No. Bad? No. And what about the was? So yes, it is was. So we have successfully converted this movie review 2 into the numerical one. Now let's just do with this 3-1. Acting. Is there any like three word in this? Yes, we have 3. What about I? No, I is not there, 0. What about border? Border is not there, 0. Awesome, awesome is not there, 0. Very, very is there, 1. And liked is not there, 0. And movie is not there, 0. And Dhoom, no, Dhoom is not there. In is not, yes, in is there, right? 2 is not there. So let's just first write it for 2, and then in is there. And then followed by much, acting, idiot, bad, was. So where is the much? There is no much acting, yes, acting, idiot, bad, yes, bad it is, and was, yes, was it is. Now you can just simply check candidate. If I just simply remove this, and instead of this, if I just simply keep this one, you can just check we have successfully converted our X data into the numerical one, into the numerical one, and the Y data into the numerical one as well, right? So can it, in this way, we have converted the textual data into the numerical one. Guys, are you getting my point? Just let me know, candidate. Where all reviews converted into this 0 and the all values converted into this Y1. Guys, are you getting my point? Just let me know. Everyone, class, are you getting my point now? Just write in the message box, do it fast. And this technique is called the count vectorizer, where we don't need to convert, like do it manually. We have some sort of module for that. and that module is the count vectorizer itself. We have to call this module with the help of sklearn module. Just let me know if you're getting my point, candidate. Then we'll start. Tejaswini, very good, right? Now let's just understand how to do this instead of doing this manually. Okay, so you can just give it, and that part is called the feature engineering, right? Or feature extraction. Okay, from sklearn, sklearn dot feature extraction dot text, you will get this that is called count vectorizer. I hope you are getting the same one, right? We no need to perform all the step manually. We have the count vectorizer class already, right? Just initialize a variable and call this class, and with this class we can just simply call this cv dot fit underscore transform, and we have to pass our complete message. Just simply pass the complete message, right? Like this. Once you run this now, you will get a matrix, and this 0 1 matrix, this 0 1 matrix is called a sparse matrix. If you are getting this matrix now, this matrix generally refer this as a sparse matrix, right? We have to convert this matrix into array. So how to do this? You can just simply write 2 underscore array, and let me just correct the spelling, array 2 underscore array, and you will get, we are not getting the answer. Let me just do it. Yes, you no need to give the underscore, right? To array is the method where you can convert this data to like this. Now we know that this is the x data na, so let's just directly insert this, store this inside x. Now we have successfully converted all our messages into the x part one. Now let's just check the shape of this x. We know that the shape of x is like the 5572 is the number of rows, and what is that? 8709. This 8709s are just nothing, are unique vocab words. And you know that unique vocab words are like this one. Here we are, just for sake of example, we are taking this one: 3i, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. 15 was the like unique word. In the same way we are getting, by combining and extracting into the vector one, 8709 are the unique vocab words, right? And the x has converted on all into the 0 1 1 0 0 1 1 0 and so on, right? Now let's just pick the y one, and we know that the y, we have like the category, and we can simply convert this to spam and ham, right? Let me just simply write the map part, and inside the map we can just simply give this like dictionary, where the spam generally treated as 1 and the ham is treated as 0. Once you run this, you will get the 0 1 value. Now you have converted this to numerical one, and if you just want to reinitialize this, or let's just directly store this inside y, right? Now you have the complete shape of x and the shape of y as well. And you know that you have the value of x as well, x like in the numerical in nature, and y as well in the numerical values. Guys, is there any doubt with any of these one? Just let me know. Because we have successfully converted the data into the x and y part, you know that the rest part is like the train test split, where you can simply give the x. Let me just give the test size. The text size is like the 20%. The random state, you already know, we have already performed everything, and you know that you can just simply give it to like x underscore train, x underscore test, y underscore train, and y underscore test, right? If we just run this, you can check the shape of all this thing. Now just simply call the model. The model, we are using the multinomial model, right? You can see this is your task. You will use the rest model like the Gaussian knife base and the Bernoulli knife base, right? Inside this model, you have to just simply use the fit and transform. The fit and transform is like the training part, right? Fit underscore training. You will get the model dot fit, and inside this fit you have to give the x train and the y train. And once you give the x train and the y train, the model try to learn the pattern, and once the model builds successfully, you can just simply check the score. The first score is your the training score. And how to check the training score? Model dot score, SCORE, model dot score, and just simply give the x train part and the y train part. Guys, we are already aware with that, right? The overall training score was the 99%. Model trained very well, right? And let's just check the test score as well. And the test score is like model dot score, and inside this score you can just simply pass the X test and the Y test, right? And just run this. This is the 98% of accuracy you are getting, right? Since this the problem belongs to the binary classification, like the 0 and 1 is spam and ham, right? So you can print the confusion matrix. Let's just call the confusion matrix, and we have to use the all matrices from sklearn dot matrices. Let's just directly import the confusion matrix and the classification report, right? I'll not print the precision score, recall score. I'll just simply directly print, print the classification report, right? And you know that before predicting the confusion metric, you have to predict the Y value, right? So let's just predict the Y pred, and you have to give the X test, right? And inside the X test, it will give you the Y predicted value. Let's just insert this inside Y pred value, and you know that the Y pred is like nothing, it's like a 0110 series. And now let's just check with the confusion matrix, and confusion matrix will give you the overall true positive, true negative, false positive, and the false negative. The first that you will pass is the Y test, and the second is the Y pred. You can just simply store inside the CM, and we know that candidate, the confusion matrix generally, this one is the true positive and the true negative. We already know that, and then followed by the false positive and the false negative. Now you can just do one thing. You can just call the SNS dot heat map. Okay, we have already performed all these tasks, right? And inside the heat map, you can pass the CM. You can just give the annotation value as like the true, and let's just show this graph pld.show, and you are getting the first one. These diagonal one are like the true classification, and these are like the false classification. If you want to change the formatting, you will get this option which is like FMT. Let me make it 0.2g. It's like the 2 float value, but we are not getting the answer now. Let me make it FMT. Let me check the documentation, right? Because you cannot learn all the things, right? SNS heat map, and FMT. Okay, this FMT is like the formatting. Okay, just go to the formatting or take a reference of this one, right? This yeah, we'll use the 2f, 0.2f, right? So let's just check with the 0.2f, and this 0.2f will like in the floating value, right? Yes, we are getting the value, right? And we know that the x level and the y level and the so on, right? So these are like 7 are like the misclassification, 9s are also the misclassification. Now because we have already like print this confusion metric, let's just call the classification report, where it will give you the complete precision recall and source code, right? You can just give the Y test and the Y pred, right? Let's just give the Y test and then followed by the Y pred. Now you will get the complete precision recall F1 score, and you are already aware with that, right? Now class, let's just build on the prediction value, where we'll just create the function. That function generally takes an email, and you have to convert that email, and just to check whether the given email is the ham or like the spam one. I'll just simply write the code. I'll give you the homework. You have to convert this code into the function one, right? So let's just take the dummy mail, right? I'll write the dummy mail with the help of ChatGPT. I'll take the dummy mail from the ChatGPT, right? Once I'll receive this dummy mail, now, what you have to do, you have to convert this to numerical one. And we know that we have the like CountVectorizer that will generally transform this dummy mail. Okay, you have to pass this inside this list dummy mail. And once you convert this to dummy mail, you can just simply convert this to array. Now, once you convert this to array, now you will get this as a dummy data, right? And whatever the model that you have just built, just pass inside the predict value of this dummy data. Once you give the dummy data, now you will get inside the array value, right? And you can store this inside the answer. And you know that the answer could be like, if the answer is equals to 1, so the answer is 1, so the given mail is the spam mail, right? You can just say. And else it is the ham mail. The ham mail is like the good one, right? Ham mail. Okay, now let me just go to chat GPT, and I'll just simply ask for the one dummy mail, right? I'll ask give one spam mail string for Python, right? This will give you me the like mail. Okay, and let's just take it as a one-liner mail, right? The mail is very huge, right? One-liner mail. Okay, now we are getting something like this. Let's just copy this. Congratulations, you have won something this, and we know that this mail is spam one. Now let's just pass this, and let's just pass this inside the triple quote 123 123, and just run this. And guys, you are getting the spam mail. I hope everyone is getting my point, right? We have just simply passed the mail here. This mail converted to array. The array, we have just tried to predict the array with the help of model.predict, that the model that we have already built, and we'll get the data inside array. We are just slicing the value. If the answer is 1, the given mail is the spam one, and if the answer is 0, the given mail is the ham one, right? You can just convert this to function one. Now you just again go to chat GPT and just ask it for the ham one, right? Give one ham mail. Give one ham mail, right? So hi John, just wanted to confirm some like this, Sarah, and so on, right? So let's just copy this, and you can just take the mail as like inside the triple quotes. Let me just paste here. Okay, and just copy the code. You have to do one thing, you have to convert this to function now, instead of directly copy and pasting now. Will not paste code again and again. Now let's just convert this to one, and now we are getting the answer as a ham mail. I hope everyone is getting my point. In this way, we have successfully built a model. That model generally takes an email and will simply predict whether the given mail is the ham one or like the spam one. I hope everyone is getting my point. Candidate, just let me know. So in this one, we have successfully created one project as well. We understood the concept of how exactly the naive Bayes is working inside the machine learning. What is the concept of like the Bayes theorem, the meaning of the naive, and how to convert the textual data into the numerical one with the help of some sort of CountVectorizer. I hope everyone is getting my point. Guys, just let me know in case of any issue, right? Just write in the message box, class. Are you getting my point, candidates? Everyone? Hello. I hope this is enough for the today. You can just take a reference from the code notebook that already been shared, and you can just try it from your side. And if you're facing any issue, just let me know. I'll try to help, right? Guys, is it good to go? Just let me know. The link and the file name or like the data set already been shared. I hope everything is good, right? Shall we just close this one? Okay, so let's just got it, right? So let's just close the recording and just try to